Hey everyone, this is Noah coming at you with another QuickNode video tutorial. In this one, I'm going to show you all how to implement a single sign-on with Ethereum in a full-stack JavaScript app. I'm going to be using the Remix web framework to show you how to do this. To start it, you're just going to run this command npx create remix. You can then create the name of your app. I did sign on Ethereum. It's going to ask you where you want to deploy. And for this, I just chose the Remix app server option. And then we're going to be doing this in TypeScript. And then do we want to run npm install? Yes. And after you have it all set up, you can go ahead and see we just changed directory into that sign on Ethereum that it created. And then we opened up VS Code. And with VS Code open, we can start seeing the kind of build of the project. But before we do that, we want to go ahead and actually get our server running. So to do that, from our terminal, we can run npm run dev. And this will go ahead and boot up our server. And now we can take a look here at what a boilerplate app looks like for Remix. So you can see we've got everything lives in this app folder. We've got our routes and then the entry for the client and server, and then the build folder and all of the dependencies and everything. And we can see here that we've got a localhost 3000, just like you're familiar with if you've been using a Create React app or Next.js. And you can see here, this is what it looks like. And what we're going to be doing is we're going to implement a login route. And from here, we want users to be able to log in or register. And so right now you can see we're at a 404 not found. But before we start implementing all of that, to have users connect to your app, typically you have a database involved. And for that, we're going to be using Prisma. And Prisma is just a nice ORM that will allow us to showcase this in a really easy way. And I use it for a lot of projects. I think it's a really good tool if you're in the JavaScript ecosystem. So to create a Prisma connection, we are going to do npx prisma init, and then we want this flag -- data source provider, and then we're going to provide SQLite. And if you just do npx prisma init, I think the default option is Postgres. But you can see what this does is it creates a schema Prisma folder. And you can see that it used SQLite, and then it's going to use the environment variable of the database URL. It also created this .env file, and you can see that it will create a file of dev.db. So from here, before we start getting too ahead of ourselves, we're going to want to create a user model. So our model will be a user, and it will have an address, and that address will be of type string, and it will also function as our ID for the database. And so with all of that added, you can see here that we've got, we can do npx prisma db push. And there we go. And Prisma actually has this pretty nice tooling where if we did npx prisma studio, you'd be able to see at localhost 555. So we'll just go ahead and create a new tab here, localhost 5555. Awesome. And so you can see now, this is like a look into your database from your browser that Prisma allows you to do. And so you can see here all of our models. So we have a user and we have 0 instances of our user model. So we'll just keep this tab open. We can take a look whenever we're done to see that we did in fact create a user in the database. So our next step on the agenda is actually creating a way to connect to the database, because if we have too many connections, it's going to overwhelm our server, because every single time that we are saving a change, it's going to rebuild and restart the server. And if we don't have any logic, we're just going to create a bunch of connections to our database and overwhelm it. So in order to do that, we're going to open up our app and we'll create a folder. We'll call this utils, and in utils, we'll have a file called db server, and that will be a TypeScript file. And we will have this available on GitHub for you. I'm not going to go over this since this is not mission critical. Just know that if you want to be doing development, this is what you'll need. I would just go into the link in the description for the repository and copy paste this. Just know this is essentially, if it's in production, it'll do a new client, and otherwise during development, we will just pick up our old connection instead of opening up a new one every single time. All right, now we can go ahead and close that and know that we've got our database situation all working. So the next thing that we'll want to do is actually create that login route. So under our routes folder, we'll create a new folder, and this will be called login. And in login, the default file is an index. And so whenever we go here, this is whenever we go to /login, it's going to look for this file, and it's going to pick up this index.tsx file. And so just to make sure that that's working, we'll go ahead and say we will export default function login. And we will return h1 tags of GM. And so here we can see, if we go to login, boom, we've got GM going. And just another quick thing to note here, you can actually see it rebuilding every single time that we're hitting save, and then it shows that we did a get login, and then we had a request of 200, where previously you could see that we were getting 404 since we didn't have that connected yet. So the next step is actually to add a button here. So let's go ahead and we can just add some parentheses here, and then we will wrap this in a div. So we'll have GM, and then we'll have a button, and that button will say connect to MetaMask, or actually sign in with Ethereum. Awesome. And so let's go ahead and get this looking good. And there we go. Oops. Awesome. And so now, whenever we go over here, we can say cool, and we click on this button, but nothing's actually happening. So let's go ahead and get MetaMask working. So we'll have, we'll call this get web3. So we'll say const get web3. Cool. And from here, we're going to use this window.ethereum object. And so if we have window.ethereum, we can start doing a bunch of stuff. Otherwise, we'll just throw new error. MetaMask needs to be installed. Cool. And you can see we're starting to get this TypeScript barking at us for this window.ethereum object. And so to get rid of that, we're going to declare global. The interface is the window object, and it can have a key of Ethereum. And that can be any. Awesome. And so with that's ETHEREUM. There we go. Window.ethereum. And you can see that lets it know that this window object can, in fact, have this Ethereum key attached to it. So if we have this window.ethereum object, we can go ahead and create a provider. So we'll say const provider is equal to a new ethers providers, and we want a web3 provider. And that web3 provider is going to be window.ethereum. Awesome. And so you can see we've got this ethers package. You'll want to go ahead and install that. So we'll say npm install ethers. And that will go ahead and install this ethers package. Ethers is a JavaScript library that allows you to easily interface with EVM-based blockchains. And so we've got our window.ethereum. So we've got our provider here. And the next thing that we're going to want to do is we're going to send a request here to the provider. And what that's going to be is a request to get the accounts. So we'll say await provider send, and this is going to ask for a method as a string. So that method is eth request account. Or sorry, it's not account. I believe it's accounts. And then an empty array because we don't have any parameters to send along with that method. And so the next thing that we'll want to do here is create a signer. So we'll say signer is provider.getSigner. Awesome. And then we'll also want an address, and we can get that from our signer. So we could do signer.get address. And then we'll also want a nonce. And we'll just do math.floor and math.random. And we'll take that number and we'll multiply it times 1,000,000 or 1,000. 1, 2, 3, 1,000,000. And that's fine. That should give us a nice number to sign. And then we're going to create a signature. And so our signature is going to be a request for our signer.sign message. And we want to sign the nonce, but it needs to be a string. So we'll do nonce to string. Awesome. And so with this address, the nonce, and the signature, if we return all of those, we can send all of that information to our server. And due to the cryptography that is used for all of these methods, I can verify that it is indeed someone that had control of the wallet is the person that signed this message. And if that is the case, they have control over it, and I feel comfortable creating an account under that address. So we'll just return all of these as an array. So this will be our address, our signature, and our nonce. Awesome. And with all of that, we can go ahead and create an onClick function. So we can say onClick, and we'll say get web3. And so we'll just check that this is indeed going to request a message here. So if we click on sign in with Ethereum, I would expect MetaMask to open up, and we can see we've got these 6 digits that are asking us to sign. And if we sign it, it says, okay, cool. And now we're not sending anything to the server, so that's all it's actually going to do right now. So our next step is actually going to be taking all that information that we can send, and we are going to send that to the server and then authenticate the user. And to do that, we're going to create another file under app. So under app, we're just going to say login.ts, and this will have our authenticate function. And so we'll just say export const authenticate. And authenticate is going to be an asynchronous function, and it's going to take an address that's a string. It's going to take a signature that's a string, and it's going to take a nonce that is a number. And with all of that, we can then say const, actually, we're going to say let authenticated equal false. And then we'll say const decoded address. And what we're going to do is we're going to take all of the information that we have, the address, the signature, and the nonce, and we're going to use a utility function that the ethers library provides us. And so that will be ethers.utils.sign message. And you can see it's not auto-completing for me because I actually need to import it. So we'll say import ethers from ethers. And our sign, I don't want to sign the message. We want to decode message. And so we don't want to decode the message. We want to verify the message. And so what verify message does is it takes a message and the expected signature that you get from signing that message. And so the only missing variable there is the address, and we can determine what that address is. So if we pass this, the nonce.toString, and we pass in the signature that we're expecting to get, what this is going to return is the address that it would take for the nonce and the signature to work together for that address. And so we can know that if our decoded address is equal to the address that was passed along from the server, we can say authenticated is true. Oh, I have authenticated. There we go. I misspelled that. There we go. And then regardless, we will just return authenticated. And so if this wasn't true, then we will return the false value because we didn't enter this if statement. And if it did, we'll return true because the address was the same. And if that's true, then we feel comfortable actually creating a user and adding that to our database. So with that, we can go back to our login function. And cool, instead of get web3, we're going to create a function called handle submit. And in this handle submit function, let's see, async function. And in this handle submit function, we will go ahead and get everything from the Web3. So we can say, oh wait, get Web3. Oop. And this will be an array. And that will be the address, the signature, and the knots is equal to the await get Web3. And from here, we can then pass all of this to the server. And to do that, we're going to need to create a virtual form that we can actually use to submit. And so we'll say const form is equal to a new form data. Actually, this will just be form data, just for, since it's not the actual form, it's just the data that's going in there. And then we're going to use this append method. And so what this is going to do is, this is, if you're imagining an HTML form, the ID would be equal to address, and that would be the input field. And so what we're going to submit is this address. And so for each of these, we are actually just going to throw in a little hack throughout this tutorial. We're just going to add some of these for the sake of speed. Typically, you'll want to verify all of the data. But for the sake of speed in this tutorial, we are just going to ignore these and know that we are in fact going to be getting them. And from here, what we can do with our form data is we can submit it. But we need to grab a function from Remix that lets us do this. So we can import a useSubmit hook that Remix exposes to us. And to do that, we'll need to go under here in the login, and we'll say const submit is the useSubmit hook. And then what we can do with all of the appended form data is we can then submit this form. And so to get that done, we can go ahead and grab this little snippet of code, and you can see that it's going to be using this action. And actions are how Remix lets you submit forms via these action functions. And so you'll see here in a minute when we wire this up that it's going to use the action from the index.tsx. And it's going to be a post request, and this is going to be the encoding type, and we're going to replace any existing fields. But all of this should be fine. And then we'll make sure that we're handling the submit. That's good. And so that's everything we need for this handle submit function. The next thing that we need to do is create an action. So like I said, we need to export const action, which is an action function. And that's going to be an asynchronous function that takes a request as a parameter. And this action function is where we can put all of the logic for what we actually want to do on the server once we send it some data. And so what we're going to want to do is, I'm going to paste some code here, is we can use this request parameter and we can request this form data. And so we can then, from our form, we can grab the address, we can grab the signature, and we can grab the knots from the relevant IDs. And so that's matches up to these IDs here on the forms. So now that we've got the address, the signature, and the knots, we can use our authenticated function. So we'll say const is authenticated, and we will just await the authenticate function. And from here, we'll pass in the address, the signature, and the knots. And you can see it's going to throw us some errors here because it's saying that we're expecting a form data entry value or null is not assignable to parameter of type string because it doesn't know all of these are form entry data values or they're null. It doesn't actually know the types of them. So we'll say, we'll actually check these so y'all can see that I'm not just going to use tsignore for every single TypeScript error that comes up. To check these, we're going to say if there's no address, or if the type of address does not equal a string, then we will return null. And we'll do the exact same thing for the signature and for the knots. Oop. And we want to go ahead and make this signature. Awesome. And so you can see now it likes all of this because we checked to make sure that for one, it wasn't null. And then we have the type of string, and number. And so from here, this will be a Boolean value. And so we can say if is authenticated is true, then actually we don't want to say if it's true. We can say if it's false. If is authenticated is false, then we will just return null. And otherwise, we're going to try to create a user. And so we'll say const user is equal to DB. And so this DB is now coming into play for that database function that we created in the utils earlier. And so this is a connection to our server, or sorry, our database. And so down here, we can say db.user.create. And we want to create a user where the data for the user is equal to the address of the address. And since this is the only field in our user, this is the only thing that we need to do. If you had like a password or a username or an email associated with your users, you would create this here. But this is the only field that we need to create here. And so the next thing that we'll do is we can actually return a redirect. And this is another nice thing that Remix lets us do. You can see that just imported it. There's this redirect from Remix. And from here, what we can do is we can return a redirect, and the first thing that it'll take is a path. So we'll say /login, and we'll say the user.address. I don't want to await that. We need to await that. There we go. And so whenever this is successful, we will redirect from that login screen to, it'll be login / the address that the person logged in with. And typically, I mean, you probably wouldn't be using the same route. This would probably just be its own thing, but I'm going to show you a couple other cool things about Remix on how you can extend and create dynamic routes. And I think if we didn't get to all of that, we should be good here. We've got the action, and that is wired up. We are submitting it correctly, and we are handling the submit. So we'll take it for a spin here. All right, and now if we click sign in with Ethereum, and we go ahead and sign it, you can see that it should take us, we've got login / and then the address that we used to sign it. And we should see over here in the Prisma Studio that we, in fact, created a user. Awesome. There we go. You can see we've got the address in there. And now, for example, if we were to go to this /login route again, that we would be able to, whenever we do this, it's going to crash because, okay, cool. It's going to fail whenever we try to create the user because this address already exists. And you can see that Remix does a pretty nice job at giving you the stack trace as well for whatever errors that you may encounter. So the next thing to try is actually getting us to this address that we had. We'll just copy this address from here. And so you can see that this isn't around the login /boom. You can see we get a 404 and it's not found. You can see really quickly that I did have to make a change to the code here. You can't do the type of signature equals number. So I just checked if it was a nonce, and then I cast the type to a number. And then also added an await here for some of these addresses and signatures because I wasn't doing that properly originally. And so the next thing that we want to do with that in mind and all of that working is actually go ahead and create a dynamic route. And the way that Remix does this is with this ampersand, or not this ampersand, the $sign. And so we'll say $, user ID.tsx. And for that, what we're going to do is create the loader function that I was talking about earlier. Actions are used to submit data using Remix, and loader functions is how we can pull data from the server. And so since we're pulling data from the database, we can go ahead and import db from the utility server, utils/db server, and then we can import the loader function and the use loader data. And from here, what we can do is same thing as before. We want to create some sort of default function. And so we'll just call this export default function. We'll call this user page. And just to make sure that this is registering for something, we'll say it returns the h1 of GM. And so now we should be able to see, if we do this, that we get GM. But the kind of fault here is that literally anything after the login is going to respond with this GM, with the 200 message. But what we want to do is we want to create some sort of way to check here, or way to pull the user data into the page. So we'll say const user equals use loader data. And so just how we had before with the action, we're going to say export const loader equals an async function. And this is going to take a params object. And so you can see in the params that it's declared, and for our loader is a loader function. And we'll want to go ahead and expect for params. You'll see we're expecting a user ID to be here in the params. So what we can do is we're going to use this library invariant. And so to install that, we can do npm install tiny invariant. And then we can go ahead and import this. And so you can see if we import invariant from tiny invariant, and it looks like it did something funny here. Invariant. And so what invariant's going to do is we're going to pass in this params.userid, and what's going to happen if this doesn't exist is it's going to throw an error saying that we expected the user ID to exist. And so this way, we're calling this loader function every single time that we are trying to load any page that sits within that /user ID on the params. And so now we can say, we can pull in a user. And so we'll say const user equals 08 db.user.find unique, where the address of the user is equal to params.user user ID. There we go. And so you can see we've got the user ID is matching here. So that's what's going to label the params as. And so if we have that, we can go ahead and just, if there's no user, we can return null. And otherwise, we can return the user. And so now, over here in this user object, we should be able to see that we've got a user right here. So if instead of returning GM, we returned, well, we can return a div, and in here we can keep the GM for the vibes, and we can also have a p tag that takes the user.address. The user.address. And you can see here that it says use loader data of any. And so we can actually put some types here that we are expecting a user right here. And where we get this user type from is actually from Prisma. So we can go ahead and import user from the Prisma client. And since our Prisma client knows the shape of the user, it automatically creates this type. And so we can already see that there's the user.address. So I think this is actually all we should need right here to see. Yeah, and you can see already from saving that we uploaded this. And so now it's saying GM with my address. And if I add a bunch of Fs here, you can see that we're getting null properties of reading the address because this does not exist. And so now we can get into error boundaries. And this is a pretty fun little thing that we can do for Remix on any of our routes. Just like for any routes, we have the loader and the action, and then we've got the default function for the actual page. We'll put this below. We can export this function called an error boundary, and error boundaries will catch all of these errors. And so instead of it showing this, we'll see here if we can get instead of this application error, we should see that we can actually make this a little bit custom now. So what we're returning is a div saying error and then the error message and the stack trace. So instead of it saying application error, we should see now that if we add some Fs here, boom, we get this typed out in a really nice way. And so now you have kind of a way to create dynamic routes for your users and then handle errors appropriately. And with that, I think that concludes the tutorial. From this, you learned how to handle errors using Remix, how to use these loader functions, how to use actions using Remix to submit data to your server, and how to use Prisma to interact with your database. And all of that will allow you to create a user with just one click of a button.